Hello everyone and welcome to PC Retro Tech. So in this week's video I want to explore the alternative world of the CPM operating system. It was introduced in 1974 and so it predates the IBM PC by quite a few years. But in today's episode I want to explore a port of CPM that was made available for the IBM PC called CPM 86. So first of all, what is CPM? Well, it stands for Control Program for Microcomputers, and it was written by Gary Kildall of Digital Research in 1974. And it's an operating system for microcomputers running Intel 8-bit microprocessors. So that would be the Intel 8080 and 8085. And these obviously predate the 16-bit CPUs that you find in a PC. It was limited to 64 kilobytes of memory and you needed 16 kilobytes to get started. And I guess that if CPM had been more competitive in the marketplace, then we might be living in an alternative world today. Gary Kildall might be as famous today as Bill Gates is. Of course, CPM was still a very popular operating system roughly in the decade before MS-DOS was. And so let's have a look at some of the machines that it would have run on. So this is the very famous hobbyist Altair 8800 computer. And yeah, that's an 8-inch floppy drive that's in that. So this used the Intel 8080 CPU, and you're probably familiar with the fact that Paul Allen and Bill Gates actually developed Altair Basic for this machine. And that was the first product of Microsoft. So this is the IMSI 8080, and it was basically just a clone of the Altair 8800. And it did actually run a version of CPM, although it was actually really highly modified for this specific machine. So another example is the Sanko 8001 computer from 1982. This is another portable machine, and it is pictured here actually running CPM. So eventually the Z80 CPU appeared, and although it used a different assembly language, it was binary compatible with the Intel 8-bit CPUs. And so eventually machines like this K-Pro 2 luggable appeared. So K-Pro 2 was actually the first personal computer produced by K-Pro, but they called it the K-Pro 2 because they wanted to compare themselves with the Apple II, which was around at the same time. And I actually remember using one of these K-Pro 2s as a very young child when I visited my father's work. They had a few of these set up there, including with the CPM operating system. So some machines famously didn't use CPM. So an example of that would be the Sol 20 computer, which is credited as being the first fully assembled all-in-one personal computer, complete with a keyboard and TV output. So it was introduced by processor technology, and they famously wanted to take their own route, and so their disk drives didn't support CPM. Competitors eventually introduced ones that did, and the company itself eventually folded in bankruptcy. So Wikipedia has a long list of computers that run CPM, and that's not to say that these are all distributed with CPM as the default operating system. I mean, nothing could be further from the truth. So the big manufacturers like IBM and HP and Xerox all had machines that used Intel 8080 and 8085 CPUs, and so they would run CPM, and in some cases they were even the default operating systems distributed with their machines. But for example, the 8-bit home computers like the Atari 800, Amstrad CPC, BBC Micro, Apple II, Commodore 64 and 128 and so on had ports of CPM either on disk or in cartridge in some cases. The other interesting thing is that the NEC V20 and V30 processors, which were drop-in replacements for the 16-bit 8088 and 8086 CPUs in PCs, would actually have an 8-bit 8080 mode which would actually run CPM. So it was a very widespread and popular operating system that could really have been the standard today, but of course it was displaced in the marketplace by MS-DOS. So to run CPM on a PC, we're obviously going to need two things. The first is a program to create a disk from an image file, and for that we're going to use copyqm. And the second thing we're going to need is obviously an image of a bootable CPM disk. And I was able to obtain those from cpm.z80.de, and if you go to their digital research page, under operating systems, they have a bunch of CPM binaries. And if you go down to CPM 86, the one that we're going to be using today is the CPM 86 1.1 bootable binary. And this actually contains a copy of copyqm and also the bootable image file. So copyqm has this CQ menu program, and all you really need to do here is to change the normal copy mode over to copy from an image file, and then away it will go. So this is what copyqm looks like running. It just first reads in the image, and then it asks you how many copies you want to make of the diskette, and then it'll ask you to insert a disk to make a copy onto. So now we can actually boot from the CPM disk that we just made, and this is what it looks like. It says loading cpm.sys, CPM 86 for the IBM PC and XT. So that then tells me that there is one diskette drive, so this is the floppy drive, but this version of CPM 86 actually also supports hard drives, and so it lists my hard drive there. Then it tells me some information about parallel and serial ports. Notice that it says I only have 64 kilobytes of memory, which of course is incorrect, but 64 kilobytes is the maximum that CPM supports. The other memory, it's put into a RAM drive called M:, and that has 576 kilobytes. Then you're sort of greeted with a friendly looking prompt that looks a lot like MS-DOS, and indeed if I type dir, it will give a directory of the disk just like MS-DOS would, but when you look here you'll see that the files are quite different. Instead of .exe files we have CMD files. So what we're going to do is play around with the CPM operating system and see how to actually use it, and then we're going to have a look at some software for CPM, including some games that will actually run under that operating system. So let's take a little bit of a look around at CPM. So there are actually some built-in commands, and I'll get to those a little bit later, but otherwise the commands are the ones that you see on the disk here, the .cmd files. So the first one is ASM86, which is an assembler for 8086 assembly language in this particular case, and that's paired with the program GenCMD. So the output of the assembler is basically hexadecimal, and GenCMD will turn that into a CMD file so that you can actually execute it. So let's move on to the next one. So assign is a program for assigning the I/O devices on the machine. So you can change where console input comes from. At the moment it's set to come from the keyboard, and console output is set to go to the screen, but you can change it so that it, for example, would go to a serial port or to a printer, and so on. So the next command is config, and if I run that, it's actually just a utility for configuring serial ports, so you can change the baud rate and parity stop bits, etc. I don't actually have anything to run on a serial port, so I'm not actually going to use that here today. So DDT86 is actually a debug utility, and it's actually very similar to the DOS debug program. So basically you give it a file and it'll load a command file into memory, and you can step through it, or you can dump memory and display the contents of the file and so on. So this is quite similar to the way that debug works, and it's called DDT. It stands for Dynamic Debugging Tool, but of course the joke is that it's named after the pesticide DDT because it's for killing bugs. Diskmate is a program for doing disk operations. So in particular you can copy disks, format disks, and even verify disks. So this is quite interesting because it's a menu driven thing, whereas of course in the case of DOS all of these were just command line programs. The HDMain program is similar, but presumably for the hard drive. It actually doesn't run on this machine. Maybe that's to do with the fact that my hard drive is formatted for DOS and is certainly not set up for CPM. But unfortunately it just says memory not available on this particular machine. So function is a program for assigning function keys, and at the moment most of those are assigned to do things that you would commonly want to do, and you can also press escape and there are some additional keys that you can assign. Pip is actually the program for copying files. So for example, if I did pip and I wanted to copy to the M drive, the RAM drive, and I want to copy assign.cmd, and I do it this way around, so I do assign.cmd, and this will copy it from the file on the right to the file on the left. And if I then go to M:, you can actually see that the file's been copied over there. Obviously print is for printing files, but I don't have a printer set up on this machine. So we'll move on to stat, and if I run that, it actually just gives me some information about the A drive. So in this case it tells me that there's 3 kilobytes of free space on A and 570 kilobytes on the M drive. Submit is a little bit like batch files in DOS, so it's for batch processing. So you create a file with a list of commands that you want to run, and then you would call submit on that file. TOD actually just stands for today, and if you run it, it gives the date of today and the time. And naturally it's 1983 and the time is just after midday, since I've just booted the machine. Obviously this is not correct. So now we're down to two larger programs, and the first of these is setup, and if I run that, it's basically a configuration utility. It's called the BIOS customization program, and it comes with a set of things that you can customize about the OS. So F1 allows you to set a command of up to 20 characters that's run every time the system is started. F2 is for saving various parameters to the disk so that when you restart CPM it remembers those. F3 sets the size of the memory disk, that's the M drive that we've seen before. F4 is for setting the step time of the floppy drive, so if you have a drive that will run really fast, you can change the step time all the way down to 2 milliseconds. F5, I don't really know exactly what that does, but it apparently sets aside some memory above BIOS for field installable device drivers. I'm not going to go into that option, but there's a second page of options, and the first is to check whether you want to enable verifying a disk after you write to it. This of course will slow it down because it has to do an extra verification pass, but it makes the usability of diskettes a little bit more reliable. So F2 is for the error message sounds that play when there's an error, and finally the F3 option here is for setting up which disk is used to store information created by the setup program, and usually this is a floppy disk, although you can also select a hard drive. In my case the hard drive doesn't actually work under CPM, and this is, as I explained before, probably due to the fact that I have a DOS hard drive rather than a CPM formatted hard drive. So the other major program here is add, and of course this is a editor. So if I want to edit a file, then I just give it a file name, and .tex seems to be a common extension for an ASCII file. It's quite difficult to use. You have to apparently imagine in your mind where in memory you're inserting information and give it commands to tell it to move here and move there. But basically, if you want to start writing something to a file, you type I for insert and then you write your text. So I'll just put this is an example text file, and then you press Ctrl Z to say that you've finished that input, and then you have to write this to the file, and finally you want to exit add. And so this will then create a file called pcretro.tac in this particular case, and if I dir the directory, you can see at the end of the listing there's the file we just created. And one of the built-in commands is type. So if I do pcretro .tex, then it's actually going to display the contents of that file, and that's exactly what we just typed. So this is a way of creating ASCII text files. So there's a few other built-in commands, and you've already seen the dir and type commands. One of them is ren for rename. So it works just like pip. I first give it the destination name, and then I use equals, and then I take the source name, and it will rename the file on the disk. So if we have a look now, you can see it's called pcnew.tac. And if I want to erase a file, then it's era, that's another built-in command, and that will take the file off the disk, and you can see it's gone. So another interesting one is user. So if I do user1, it will actually switch to a new user area on the disk, and you can see that there's nothing in user1. All of the files that we have on the disk at the moment are in user area 0. So the one final built-in command that I know of is save. I won't show this in operation, but basically it's used to save pages of memory directly to files on a disk. So if you were hexadecimal editing something in memory, then you could actually just save that directly to a disk from that memory location. So let's now load up some programs that run under CPM, and we'll see if we can find some games. So I managed to find a cache of CPM programs that I can actually run, and most of them require a VGA adapter, so I've installed one in my XT here. I also needed to install a program to copy DOS files over to CPM disks, and so I used a program called 22D for that. So this is the first of the programs that runs under CPM. It's called Bouncy, and as you can see, it's a little ball that's just bouncing around on the screen. And many of these little demos are like this. They're written in Turbo Pascal and quite slow, and a few of them are actually ports from DOS programs. But most of these are written specifically to run under CPM directly. So the next one is called 2D Star, and it starts by fading the terminal to black, and then in a moment it'll start drawing a star field. Now it's called 2D Star because it's just drawing 3 different layers of stars, but in a two-dimensional way. And in a moment it'll start scrolling each of the different layers at different rates to give the appearance of movement. And so once you're finished with that, you can press escape and it'll fade this back to the terminal again. So the next one is called 3D Star, and this one tries to do a 3D star field. As you can see, it's very slow, and this is only to be expected since this is using Turbo Pascal, and probably it's using a very, very slow graphics driver. But anyway, it does give you an idea of what people have been doing for fun on CPM. So the next one is called LC for line color, and basically you type LC and a color. So in this case I'll just type 2 for green, and it'll change the color of the status line at the bottom that's always displayed when you're running CPM, and it's now green instead of the magenta that I just had previously. Unfortunately Fastbot doesn't run. It says memory not available, but I can run Beth, which is actually written in assembly language, and you can see that it displays some vertical bars on the screen and then scrolls them over to the left very, very slowly. So this is not exactly highly optimized assembly language, I would say, but nonetheless it's still interesting to watch. So the next one is Bob's, and it's actually written in assembly language. It's supposed to give a shade Bob's implementation. But unfortunately, as you can see, it's really, really slow. So I think that whoever wrote this hasn't actually optimized the assembly as much as is possible. The next one is called Piano, and it gives you this single octave piano. And basically, if you hit the numeric keys, then you get sounds. So QX Font 2 is a program for installing a different font. It's designed to give you a more of a realistic experience. It gives you a sort of green screen appearance, and a font that might be more familiar to people who actually used one of these machines with CPM back in the day. So I got these programs from z80cpu.eu, and there's quite a list of programs there. Some are just utilities and others are games, and a few are just graphical demos like the ones that I've shown. Not all of them run. Some of them require more memory, and I'm not actually sure how one enables more memory. Later versions of CPM were able to break the 64 kilobyte limit. Perhaps it's just enough to reduce the size of the RAM drive, I don't know. So now we're going to look at some games for CPM, and of course there are some text games, certainly some famous Infocom text adventure games that run on CPM, but in terms of graphical games you can't expect very much here, because after all they have to run on an operating system, CPM, that was around before the PC. But they have to run on an 8086 processor, which is the CPU in the PC. And so there's not a lot of intersection there, and this means that there are very few games that have actually been written for CPM 86, which are of a graphical nature. So for the first game, we're going to look at Pong 2. Tic-Tac doesn't work, unfortunately. So it says that it's an adaptation of a basic program. So I want it to run as fast as possible because this is not a particularly fast machine, and I'll need Z and M for paddle movement. So I'm going to pick a large paddle, of course, because I'm a beginner, and let's see if we can play this. So you can see that even though this is on the fastest setting, it's still not really very challenging to play this version of Turbo Pong. In fact, it's really not very much fun to play at all, and again I think that the reason for this is that it's been written in a programming language which really just isn't fast enough for this kind of machine. And very often I think people were writing these programs on 386 and 486 machines, or even later, and this is why they are running so slowly, because on those machines they wouldn't have noticed any performance issues. So this is Tetris, and you can see that it's actually a text mode game rather than being graphical. The performance is therefore quite good, but unfortunately it's just not very visually stimulating. This is Gulper, and it's some kind of Pac-Man clone, but again it's a text mode game. Normally the background would probably be black here, but I've actually got a red background because one of the other programs left the console in a different state than normal. So anyway, this is what Gulper looks like, and again, it's playing quite well, but it's just not a graphical game, unfortunately. So this is tic-tac-toe, and of course if you get the chance to start first, you can force either a draw or a win, and in this particular case I'm going to get a win out of the game. Limited entertainment value, I would say, compared to the average DOS game, but still a good example of the sort of thing you could expect to do you know, in your lunch break on a CPM machine. This is a very classic game, Hangman, and obviously I have to guess the words, so I'm just going to try some vowels first to get some idea. And it tells me there's a U, so I'll try a P, and let's see, 8 tries left. I need maybe another vowel to give me an idea here. Nope, still nothing. So S, stupidity, there we go. And that'll bring us to the end of today's video. So I hope you enjoyed this look at the CPM operating system. It's certainly a blast from the past, and not at all what you would expect from the DOS operating system, where there was a real rich game ecosystem that developed very, very quickly. Instead, CPM was much more focused on productivity and business applications. Anyway, that's it for today, and thanks very much for watching. I hope you enjoyed this, and we'll see you in a later video. Bye.